Yeah. Okay. Let's start. So previously we defined centroid, no, centroid to be the point wherein the gravity will be concentrated. It's the center of mass, and it's a point wherein the masses will be concentrated. And when we refer moment of mass, this one, we define moment of mass as the distance or the product of the distance of the particle to the reference axis and its mass. That's R times M. And we have two moments. Dalawa yung moments natin. We have moment in X, right? And moment in Y. So when we are referring to moment in X, we are looking for the moment with respect to the X-axis. And moment in Y, we are looking for the moment with respect to the Y-axis. Okay? So, and this R, so yung with reference to the x-axis, the moment of x is equal to rx times its mass, and moment in y is the distance to the y-axis, that's ry, times its mass. Okay? And then when we talk about the centroid for the rectangular region, when we are referring to the rectangular region, this one, so we locate the centroid to be the center, okay, of the rectangle. Say for example, this is your y-axis and this is the x-axis, right? So we define centroid to be this point, such as the distance from this point to the y-axis, you call it bar x, and the distance from this point to the x-axis, you call it bar y. So the centroid is denoted by bar x, bar y. Okay? And then when the area is concerned, we define moment in X to be the product of A, the area, times its bar Y, okay, because this one is the bar Y. And when we are referring to moment in Y, that's the area times bar X, okay, which means when the area is concerned for area, for area of rectangular region, bar x is equal to moment in y divided by the area, and bar y is equal to moment in x divided by the area. And this is equal to, you just recall, that's the integral of what? Xc, right? Xc, this one. It's xc times the differential of area evaluated from A to B divided by the integral of the differential of area. This is how we compute for the area of that region evaluated from A to B. Whereas bar y is equal to the integral of yc bar y, that's moment in x, so that's yc times the differential of area evaluated from A to B, all over the integral of differential of area evaluated from A to B. Okay? And then, let's move a little forward. So we will apply the same principle when we're looking for the volume of the solid of, when we're looking for the centroid of the volume of the solid of revolution. Okay? Say you have this kind of solid. Say, I'll just refer to a cone na lang. Oops, sorry. And this is the axis of revolution. So you would know that, again, the axis of revolution is the axis of symmetry. And we say that by using this principle, that the centroid center, okay, has something to do with the center. So it's located exactly at the midpoint or the middle, exactly at the middle of the rectangular element. So, which means when we are looking for the centroid of the solid, so it will fall on its axis of symmetry. So it might fall on, it will fall on the axis of symmetry, okay? Because that's the center. Okay? The only thing that we need to look for is on what portion of this line can we find the centroid. It could be somewhere here, here. The conclusion is the centroid can be found on the line of its symmetry, on the line of symmetry. Okay, and again, by using this principle, you know that the volume times bar x is equal to the moment in y. Okay? And then the volume times bar y is equal to moment in x. And that is written this way. Bar x is equal to moment in y divided by the volume. Can you still hear me?
Yes po, sir.
Thank you. And bar y is equal to moment in x divided by the volume. And so instead of dA, we will be using dV. And you recall, how do you compute for the differential in volume? dV can be computed in three ways, either by cylindrical disc, the washer or the ring method, and the cylindrical shell method. Okay, there are three ways on how to compute for dV. And then this is what you need to remember, that the centroid of solid of revolution can be found on its axis of symmetry. Axis of symmetry. And what is the axis of symmetry of the solid? That's the axis of revolution, which means we only need to get one component of the centroid. Whatever the axis of revolution is, then that will be one of the components of the centroid. It's either bar x or bar y. And when the solid can be divided into two or more solids, then bar x is equal to V1 bar x1 plus V2 bar x2 running until Vn bar xn divided by the sum total of all the volumes. Or V1 bar y1 plus V2 bar y2 running until Vn bar yn divided by the sum total of the volume. Okay, so you recall this formula, obviously this one. And let's take some example. I'll be using the examples that we have already discussed for the volume. Oops, hold on. Wait lang. It's hanging up. Oh, wow, wow, wow. Hold on. Can you still see my screen? Let's start from the top.
Yes po.
Okay. And then let's take this problem. Again, let me just remind everyone, I will not discuss the volume. I will not compute for the volume. I will just only be teaching you how to compute for the centroid of the volume. Okay. Then let's take this problem. We'll just modify this one. Instead of the volume, we will be computing for the centroid. Find the centroid. Oops. Of the volume of the solid generated when the region bounded by x minus y plus 1 equals 0, y equals 0, x equals 0, and x equals 1 is revolved about the x-axis. Okay, and this is how we do it. We first get the points of intersections. That's negative 1, 0, 0, 1, and 1, 2, and we trace it like this. And then after which, you identify the element. So in this case, we choose vertical element because that's the easiest method. When we take horizontal element, there are two slices, and then we revolve it over the x-axis, and we generated this region or this solid. Okay, and then we compute for the volume. I'll just copy it here. We have what method are we going to use when you see the figure?
Cylindrical disc po.
Why is it again cylindrical disc? Can I hear someone?
The rectangular element po is perpendicular to the axis of revolution.
And
The
one more.
element is touching the axis of revolution.
That's it. Good. Okay. So we have already computed it, and then let's go on to the centroid. Okay. Let us locate, and one more thing. We know that the axis of revolution is the line of symmetry, and the axis of revolution for this problem is the x-axis, whose equation is y equals 0. Okay. That's y equals 0, which means we now have our bar y. Bar y equals 0. And then we only need to look for bar x. Okay? Now, the question is, what moment is associated to bar x? Is it moment in x or moment in y? What moment?
Y po.
Moment in y. So we need to look for moment in y. We go back here. That's moment in y. This is the y-axis, and this is the x-axis, and this is bar x. the distance of the centroid to the y-axis. So that's moment in y, which means we need to have, when we're looking for moment in y, we need to have xc. And then look for xc. If the element chosen is vertical, xca is what?
X po.
That's x. Okay, you recall that one, huh? Let me just draw you to our, where's it? Here. Okay, this is what you need to remember for xc and yc. When you're taking element vertical, okay, that's vertical. So xc is always x. Xc is always x, regardless whether the element is touching or not touching the x-axis. Basta ang xc ay x. Okay? This is not touching the x-axis. So that's it. X is x. And yc, if it's not touching the x-axis, that's 1/2 of y upper plus y lower. Okay? You recall this theorem, ha? Well, as far as the use of horizontal and vertical elements is concerned in solving for the area and the volume. Okay? So, which means, going back to the problem, here, x is x. So, what are you going to do now? For the moment in y, it's just as simple as you go back to the volume, because this is our dv. You get this equation, okay? Just copy this equation. So that is pi, I'll just write it here. Pi times the integral of x plus 1 squared dx. This is the computation for volume evaluated from 0 to 1. And then what you need to add is this xc. And then you just affix xc here. So that's x. And you are now ready to integrate. That's the only thing that we added on the concept of the centroid and volume of solid of revolution. So you just expand. So that is pi from 0 to 1, x, that's x squared plus 2x plus 1 dx. And then you just introduce x each term inside. So you have pi from 0 to 1. We have x cubed plus 2x squared plus x dx. Am I right? Then pi, can I now integrate? Yeah. Am I doing it right? Kindly check my computation. Plus x squared over 2, evaluated from 0 to 1. Can you still hear me?
Yes, sir.
Okay. Yes, sir. Okay, and then we now replace x by 1. I am now replacing x by 1, ha? And then by 0, and I think the rest will become 0. If we take the LCD, that's pi. Then 432, that's 12. 12 divided by 4, it's 3. Times 1, it's 3. Then 12 divided by 3, it's 4. Times 2, it's 8. Then 12 divided by 2, it's 6. Yeah? Times 1, 6. Then we add them all. This is 17. So we have 17 pi over 12. This is our moment in y. And then we can now compute for bar x. We say that bar x is equal to moment in y divided by the volume. So you now have moment in y, 17 pi over 12 divided by the volume. We have already computed this one. So that's 7 pi over 3. And we now have 17 pi over 12 times 3 over 7 pi. Then simplifying, we shall have, this is 12, 3, so this will become 4. Then you can drop this pi. So 17 over, I think it's 28, right? Yeah. And therefore, the centroid can now be found at 17 over 28, then bar y is 0. 17 over 28, 0. And you have to check whether this is still inside the solid or not. If it is outside the solid, then we got it wrong. So 17 over 28, can you execute this on your calculator just to verify? It's something like 0.
Is it the Wilmer dot Castillo?
What is the result?
Thank
So
you.
it's located somewhere here.
0.6.
0.64.
0.6.
So this is where we can find the centroid. What is this? It's 1. So somewhere here. So this is where we can see the centroid, 17 over 28, 0. Okay. Yeah, this is easier than the area, centroid for area, kasi we are computing for the components in area, bar x, bar y. But in volume, we only need to compute one component of the centroid. It's either bar x or bar y. Okay, one more. Any question? Hello? Question? None?
Wala naman po ako.
Okay, thank you. And then let's move to the next problem. I'll be getting it here again. Let me see. Let's try this one. Okay lang. No, not this one. Ito na lang. Kasi this is another problem because the element chosen is horizontal. The first one is vertical. Let me just copy it here and then let me modify the problem. Find the centroid of the volume of the solid generated when the first quadrant region. Okay, and then let me first get the volume. The volume is 8 pi. And you have to take note that the axis of revolution is the y-axis. Right? There you go. Bam. Okay. So let's analyze the problem. So this is the axis of revolution. The line x equals 0. It follows that you now have your bar x, and that is 0. All right. And then you only need to look for bar y. And then what moment is associated to bar y? This is the centroid. And this is YC. And this is your XC. Okay. That's bar Y. What moment? Moment in?
Expo.
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 Good. So what do we need to have? YC. So what is YC? YC. We are taking element that is horizontal.
Y. Y po, sir.
Okay, that's Y. And then we now compute for the moment. Moment in X. Okay, so you have, we will just copy this once more. Okay, literally, we will be copying this part. That's pi. Integral from 0 to 4. And then you have square root of y, and then you add yc. Yc is y, and then this is your dv. Square root of y squared dy. Can I ask someone to solve this? Okay, kindly solve this on your sheet. You want? You do it on your sheet, ha? While I'm doing it here. 0 to 4. Then this is y square. We only have y square here. dy. We have pi 1/3 y cubed upwards from 0 to 4. Then what is your moment in x? Come on. That is
64 pi over 3.
4 over.
Pi over 3.
4 pi.
all right. 64 pi over 3. Then we're now ready to look for bar y. That's 64 pi over 3 divided by 8 pi. Or you just multiply it by the reciprocal of the volume. 1 over 8 pi. And then bar y, you can just drop pi. Then 64 divided by 8 is 8. So that's 8/3, I think. 8/3. And then therefore, the centroid can be found at x equals 0, bar x 0, 8/3. So 8/3 is 2 point something. I think we're still on this part of the solid. Yeah. Hindi siya wala siya sa labas. Okay, nasa loob siya ng solid. All right. One more. Let's get some problem here. This one. I hope you're getting this right, huh? Let's modify the problem again. Find the centroid, okay, of the volume of the solid when the first quadrant region bounded by y equals x squared, y equals 4, x equals 0 is revolved about x equals 2. Then we get the volume. The volume is 40 pi over 3. What method is used here?
Ring or washer po.
Why?
Yung
Because?
element po ay perpendicular to the axis of revolution.
And?
But the element is not touching the axis of
Touching.
revolution.
Okay. So at least you're getting it right how to compute for this the volume. So let's locate our centroid. We will locate it here. And then again, this is your YC and this is your XC. It follows that we have our axis of revolution, which is x equals 2. So it follows that bar x is 2. So we only need to look for bar y. And the moment of x is associated to bar y. So we need to look for YC. So, okay, try to figure it out. The element chosen is horizontal. YC is?
Y po.
Y po. That's it. All right. And then, let me just get this part of the volume. And then we will make this our moment. Oops, hold on. One more. It's literally kinaka-paste ko lang siya kasi that's the idea of the centroid. And we are just adding some XC or YC here. Okay. And this is our moment in, what is this? Moment in X. And then, so separate ko lang to. Oops, one more. You see that? Di ba ito yung sinasabi ko sa inyo? When I start discussing some applications of definite integral, I always tell you that you have to remember the x right, the x left, okay, the y upper, the y lower, because that will still be used until the end of the semester. And we have to put YC here. So there's Y here, Y, that's YC, and then another one here. And this will be the last part. Then you have Y. Then we now compute for it. Mx equals pi integral from 0 to 4, then times 4. Y times square root of y is y raised to 3 halves minus y times y is y squared. And then kindly integrate this. What is the result? You're doing it right. Okay. 5, 4, raise to 5 halves minus 1/3. Then 4 cubed, that's 64. Then the rest will become 0. You have, what is this? Equals pi times 8 over 5. This is the square root of 4. 2 to the 5th power is 32. Minus 64 over 3. And yeah. Then we can factor out 32 to make it a little simpler. 32 pi times 8 over 5 minus, there will be 2 here, over 3. All right, am I right? Then 32 pi, then we have 15 here. 15 divided by 5 is 3 times 8, 24. 15 divided by 3, it's 5 times 2, it's 10. So 24 minus 10, it's 14. And then kindly multiply 32. I have 32 times 14, 8, 1, 2, 2, 3, 4, 4, 4, 8. Yeah, I think. Moment in x is 4, 4, 8 pi all over 15. Am I right? Kindly execute it on your calculator.
Tama po, sir.
All right. And then make it a little smaller so that we can have our bar y. Bar y equals 4, 4, 8 pi divided by 15 over 15 times the reciprocal of the volume, 3 over 40 pi. Then you can drop pi off. So this will become, cancel this out. This will become 5. We divide this by 4. 1, 1, 2. By 4, it's 10. So by 2 again, it's 56. So bar y equals 56 over 5. Oh, over 25. Yeah. All right. Yeah, I think. Therefore, the centroid can be found at 2, 56 over 25. 56 over 25 is 2 point something, and I think it's still located somewhere here.
2.24 po, sir.
2.24. So this is 4. This is 4. So kalahati. This one is 2. Yeah. And then 2.24. This one is 3.5. And then somewhere here. Somewhere here. Yeah. And this is where we can find our centroid. At 256 over 25. All right. Let me see. Okay, one more. Diba, mamadali lang siya kapag alam niyo yung concept ng volume. Dadagdagan nyo lang ng XC at YC eh. And what about this one? Dito na tayo. Okay, this problem. This time, we will be using cylindrical shell. Alright, so again, let me modify the problem. Use cylindrical shell method to find the centroid of the volume of the solid generated when the region bounded by y equals 3x minus x squared and y equals x is revolved about the y-axis. Okay, all right. Then let me just copy this volume. Okay. And the volume is equal to 8 pi over 3 by using shell method. Okay. Then analyze natin. The axis of revolution is the line x equals 0. So you now have bar x is equal to 0. We only need to look for bar y, and we only need to look for the moment in x. Kasi we're looking for bar y. So we locate our centroid here. From here until here is your XC. And then from the centroid to the x-axis is your YC. And since we are looking for moment in X, we need to look for YC. Now, earlier, we have seen that when the element chosen is vertical, XC is X. One more. When the element chosen is vertical, XC is X. Now, what will be our YC? The element is vertical, not touching the x-axis.
Yo.
1/2
Y
times
upper
Y
plus
upper
Y
plus Y
lower.
lower po, sir.
Okay, thank you very much. 1/2 Y upper plus Y lower. And then 1/2, what is Y upper? Y upper is this parabola downward, and that is defined by the equation 3x minus x squared. Minus Y lower. This is our Y lower. That's the line Y equals X. So Y minus X. Or plus, sorry. Then you now have 1/2 times 4x minus x squared. Right? And this is our YC. For the moment in X equals integral of YC 1/2 for x minus x squared. And then we need to get dV, the volume from here. Where is it? Okay, this one. Okay, we'll just copy this. 2 pi, the limit of integration. Oh, why is it 24? 2 pi. And then the limit of integration is 0 to 2. 0 to 2. And then you just copy this one. Okay, 2x squared minus x cubed. I hope you are getting this right. And then we just simplify. Then 2 pi times 1/2, it's pi. 0 to 2. Then you just multiply. 4x, 2x squared. It's 8x cubed. 4x times negative x cubed is negative 4x to the 4. Negative x squared, positive 2x squared. Minus 2x to the 4. Negative, negative, plus x to the 5 dx. And then we just combine these two. You have pi 0 to 2, 8 minus, 8x cubed minus 6x to the 4 plus x to the 5 dx. Can you still see the handwriting kapag siya ay red or malabo pag red?
Kita
Okay
po.
lang.
Kita
naman
po, sir.
Then integrate natin. So this is 8x to the 4 over 4 minus 6x to the 5 over 5 plus x to the 6 over 6 evaluated from 0 to 2. So you have pi, 8 over 4 is 2, 2 to the 4, 16 times 2, 32, minus 2 to the 5th power is 32, plus 2 to the 6 is 64. Just correct me if I'm writing this incorrectly. Then the rest will become 0. So minus 0. So I can factor out 32 again. 32 pi, 1 minus 6 over 5. Or you can execute this on your calculator. Plus 2 over 6. And 2 over 6 is 1/3. All right. And then you have 32 pi. I think this one is 15. 15 times 1 is 15. 15 divided by 5 is 3 times 6, it's 18. 15 divided by 3, it's 5. So you have, what is this? Negative 3, it's 2. So we have mx. Moment in x is equal to 64 pi over 15. Then, we now compute for bar y. Bar y equals 64 pi over 15 times the reciprocal of the volume. That's 8 pi over 3. So it's 3 over 8 pi. Then bar y equals 64 divided by 8 is 8. All right. Then you can drop pi off. Then 15, 3, it's 5. Therefore, the centroid can be found at bar x, 0, Oops. Oh yeah, it's 0. 8/5. All right. Okay. All right. Then just raise your question if you have question. um, Next problem natin, application of this remark number 2. We say that when the centroid can be divided by 2 or more solids, then yeah, I'll give you an example of that. And this time, we will get it from this illustration. Where is it? Let me just close this part. Then, ito na lang siguro. Where is it? Ito na lang. Okay, yan. Ito yung problem natin. Let me just copy it here. Sinol ba natin to before? No, hindi. Okay, anyway. Okay lang. Okay. Okay, here's the problem. Find the volume this time. We'll modify it. Find the centroid of the volume of the solid generated when the region bounded by x plus 2y equals 2, y minus x equals 1, and 2x plus y equals 7 is revolved about the y-axis. And the region can be divided into 2 or more sub-region. This is first, second region to be revolved over the line x equals 0. Okay, so we already have our bar x. Yeah, and this is how we compute for the volume V1. We have small r1, capital R1. That's 14 pi. V2 is 10 pi. Okay, so we are using the washer or the ring method, and then the total volume is 24. And then actually, this problem can easily be solved, the volume can easily be solved by applying the vertical element or the shell method. Mas madali siya sa shell method. But then again, when we are referring to the centroid, I think it would be better if you use the horizontal. Why? Because of this concept. The x-axis overlaps with this element. So the question is, sir, what would it be? Is it YC should be y 1/2 y upper plus y lower, or 1/2 y upper minus y lower? Okay? So what do you think? If this happens, you still need to choose 1/2 of y upper plus y lower. So, but we will be using the horizontal element. Okay. Then you'll have 2 centroids. Just erase this part. You'll have 2 centroids. For this one, I'll use green. And this one. This is C2 and this is C1. This is your X C1 and this is your YC2 pala, sorry. And this is your YC1. Why am I? YC1, this is YC2, and this is XC2. Okay? Then, you know that the axis of revolution is the y-axis. So we say that bar x is equal to 0. We only need to look for bar y, and we only need to look for moment in x1, and moment in x2. Okay? Dalawa yon. And when we are referring to moment in x1, we need to look for yc1 and yc2. Since the element chosen is horizontal, yc1 is y. Yan, y. Kasi dito sa vertical element, ang yc1 nyo is 1 half y upper plus y lower. Same with yc2, which is 1 half y upper plus y lower. Ito, y lang. Okay? And then, what are you going to do next? You just copy this one. These are your volumes. You just copy this one. And place it here. And then we are now ready to compute for the moment. This is moment in x1 and this is moment in x2. Moment in x1, so we add y in front. Moment in x2, we add y in front. Okay, and then kindly work on this problem, please. Thank you. So we solve for those moments. You do this on your sheet, ha? Thank you. And then we compute for bar x. Oh, no. Bar y1 equals moment in x1 divided by v1 equals v1 is 14 pi. Then bar y2 equals moment in x2 divided by v2. Then v2 is 10 pi. Okay, yeah. Can you do this first? Thank you. Thank you for this one. You just expand this one, ha? Ito, expand nyo to. Expand nyo to. Then you just combine before you add that y in front. Let me execute it on my calculator. Seven over 2 minus 1 half y square minus 2 minus 2. Two minus 2, yeah, square. Evaluated from -1 to 1. All right, it's 14 pi. Sorry, I forgot to include y in front. My calculator says it's 3. This is 3 pi. 3 pi, sorry. So this is 3 pi. So you have 3 over 14. All right, and then itong isa, it's 1 to 3. It's y minus 1. Can I ask someone to send the solution on the group chat? It's y minus 1 square. My calculator says it's 17. 17 pi. Yeah. Then we now compute for the bar y is equal to, you have v1 bar y1 plus v2 bar y2 all over v1 plus v2 equals, you have 14 pi plus 10 pi, and then v1 14 pi times y1, it's 3 over 14. Actually, you may not include pi anymore kasi at the end it will be cancelled out, plus v2 10 pi times 17 pi over 10. Why there's pi here? All right, and then okay. Sorry. Tama, may pi dyan. Nalimutan ko lang kuhanin yung y2. Then, yeah. So you can drop that off. 14, 10, 3 plus 17, it's 20. So that's 20 all over 14 plus 10, 24. And this is equal to, divide by 2, 10, divide by 4. It's 5 over 6. Right, and then therefore, the centroid can be found at bar x is 0, and then 5 over 6. Yeah. All right. Have any question, clarification?